Well, good evening everybody. I haven't made a video in a couple of days. This is continuing on from the embedded code design module. Before, if you've watched my videos, you will have seen that I used a PIC and the MCP port expander using SPI to do read and write functions, sending data in both directions, and that was fine. The intention of this was to actually implement the PIC with the Altera DEO board. And then we ran into some problems with that because the VHDL hardware element for the SPI module on the DEO is quite buggy. I guess Altera never got around to fixing that. I don't think one of the chaps said it hasn't been updated since 2008 or 9 or something silly. So we had to go back to the drawing board a little bit. So rather than running the PIC in master mode, we have to run it in slave mode, with the DEO being in master mode. Now, having never run a PIC in slave mode before, this is an interesting challenge. I thought it would be really simple, but it turned out to be quite a slog. Before you can see there are two copper strip boards, both with identical PIC microcontrollers on there. They both have 20 MHz oscillators, crystal oscillators. The idea basically being is over here, as you can see, there's 5 PTMs. They're connected to the master PIC. And there's 3 lines going between the two PICs, the data in, data out, and the clocking line. And then the output over here is a bunch of LEDs. Obviously the idea is that I can send a series of packets, a series of messages from this one to that one. The slave should be able to pick them up and then do something with the data, cause a response on the LEDs. So I'll show you that quickly. There you go. Interestingly, you may have seen that a second ago where all of them flashed. That was actually a warning I put into the code if there's an overflow in the buffer. So if there's something in the buffer on the slave, and then there's some of the data on that is overwritten, again before it has time to process it, it triggers the overflow bit on the SPCon, I think it is, SPCon, or it might be the SPstat, I can't remember. I think it's the SPCon register. And that's just warning me, and I have to manually, in software, reset the flag there. Yes, as you can see, normally it works totally fine. You can zip up and down. I've only got 5 buttons and there's 7 LEDs. That's why they're not all showing up there. So the next step is doing this in reverse. This was surprisingly difficult. There wasn't much information available online, and the data sheets are, the data sheets, they're normally pretty good, but they're not necessarily the best at explaining everything. The SSPCon register, when you're in slave mode on the slave microcontroller, was a bit of an issue for me. I managed to get this working, but it only worked once, and that was when I had the slave select line in. And I couldn't work out why, because I could program the device and run it. I could press a button and it would change once, and then the program would die. The PIC would just stop working altogether, and I couldn't work out why. It turns out that the last 4 bits on the SSPCon register, they have a mixture of things on there, but one of the things is to disable or enable the SSP pin. So that's the slave select line. I tried disabling it, and now it works perfectly. So I'm not actually 100% sure exactly why that works in that way. I will have to endeavour to find out more about it. But for the time being, it doesn't really matter. I'm happy. So next step will be, as I say, putting some buttons on the slave, putting some LEDs on the master, and having two-way communication between these. And then hopefully, with that on board, it should be fairly straightforward in creating a few packets and sending the information to DEO and back again. So thank you for watching. I'm sure there'll be some more videos to come. The next also, once this is all working, I'll create a schematic of the full system, for the PIC side, for the LCD screen, the analog sticks, the SPI and the DEO and the ARM, and then generate a PCB. I'll probably use dip trace again and create my own PCB, as I now have a UV light box and all the chemicals necessary and some copper clad board. So I'll definitely put up a video about that when I get around to that. Thanks for watching, and see you later. Bye bye.